Today we're going to learn how to carry out a one-way ANOVA using Jamovi. The one-way ANOVA is simply the generalization of the independent samples t-test to more than two populations. So the scenario we're going to look at today involves an individual's critical flicker frequency. You might not have heard of this before, but it's the highest frequency at which the flicker in a flickering light source can be detected. So, if you see a light flickering, it generally is unpleasant. But if it actually flickers fast enough, you can't actually see that it's flickering and it appears to be continuous, even though it's actually flickering. So what happened is there was a study with 19 subjects, and they determined what is the highest level of flickering or the critical flickering frequency for those individuals based on their eye color. We're going to test this hypothesis at the 5% significance level. So if we go to Jamovi, we can see that we have our 19 individuals. Their eye color is in the first column, and their critical flicker frequency is in the second column. We're going to run an ANOVA, a one-way ANOVA, and our dependent variable is the flicker rate. It needs to be of the ratio or interval level of measurement, and your grouping variable is categorical, where you have two or more categories. Since it's a one-way ANOVA, it's typically at least 3 categories. And if we look to the right, we see that we have a p-value of 3%. That is less than our level of significance, so we're going to reject the null hypothesis and accept the alternative hypothesis that eye color matters, that somehow different eye colors have a different critical flicker frequency on average. Now, the one-way ANOVA is a multi-sided test, so this doesn't tell you which population has a higher or lower one. It's just saying there is a difference. But if we look at some graphs or some tables, it might give us an indication. So if we look at a descriptive table, we see that we have those blue, brown, and green eye colors. And it seems that blue eyes have a higher mean, at least in our sample, than the others. That is, they can detect a higher frequency on average of a flicker in a light. If you like a graphical display, you can click on descriptive plots, and you can see the side by side plot, 95% confidence interval plot for these 3 different eye colors. And you can see here that there is some evidence, some pretty significant evidence, that people with brown eyes have a lower critical flicker frequency than someone with blue eyes.